All right, so these are the skills that I think that you're currently struggling with here that hopefully this video is going to help you out with. First one is just going to be dilating by a scale factor. Okay, so when we're dilating by a scale factor, what we're doing is we're taking some object, so in this case we have a triangle ABC, and we are going to either increase or decrease the distance that this object is from our current center point. Okay, so they tell us that the center is D, so here's our center point over here, and they tell us that the scale factor is 2. Okay, so what they're asking us to do here is they're asking us to make this figure twice as far away, so every single point of this triangle is going to be twice as far away from our center as it currently is. I'm actually going to go ahead and move our center here, and I'm going to go ahead and stick it over here. Alright, so center D, let's say that we measure our distance. Let's measure our distance from our center point to A first. So center point to A, I'm going to draw a line that goes from our center D through A. Okay. Let's say we measure this thing and it is exactly 1 centimeters away. So from our center point D to A is exactly 1 centimeter. If we're dilating by a scale factor of 2, that means we are going to double that length. Okay, so what we're going to do is we're going to find 1 centimeters times 2 is of course 2 centimeters. That is going to be the new distance from our center point to A. So this is going to be A prime. Okay, so our old distance from our center point to A was 1 centimeter. Since we're using a scale factor of 2, we are going to multiply that old length by 2 to get a distance of 2 centimeters. So this is now 2 centimeters away from D. Alright, so we're going to do this again. We're going to do this 3 times. So for each vertex or each corner of our triangle. So now I'm going to draw a line from our center point through point B. Okay, and let's say that we measure this length with our rulers and we get 2 centimeters. So our old length of this segment is 2 centimeters. We're going to multiply that old length by our scale factor of 2, and that's going to give us 4. So then we're going to measure from our center point along this line until we hit 4 centimeters. Let's say that's around here. And this is where our new point B is. So point B prime is going to go there. Lastly, hopefully you're starting to see where this is going here. We're going to measure from our center point through point C. Okay, so drawing with your straight edge a line that goes from our center point through point C. And let's say that once again this is 1 centimeter. So let's say that this length here from D to C is 1 centimeter. We're going to multiply that length by 2 as well, and we're going to get a distance of 2 centimeters. We're measuring from our center point along this line until we get to 2 centimeters. And there is C prime. Okay, so we're going to now go ahead and connect these things up. Let's go this color here. I'm going to now connect each of these new points here. So I'm going to connect A prime, B prime, and C prime. And what we're looking at is a triangle that is, and should be, if you use your straight edge here, should be exactly twice as big as your original triangle. Okay, so it should be same shape. The angle should be the same. So this angle and this angle should be the exact same. This angle and this angle should be the same. And then each of our side lengths should have doubled. Okay, so that's dilating your original figure, ABC, with a scale factor of 2 with center D. So we have doubled the distance to each of our points. Okay, let's go ahead and do a new figure. So I'm going to get rid of all of this here. And you can pause the video as you like and see if you can kind of guess where we're going with these. So I'm going to go ahead and change this now. So let's say you're asked to dilate triangle ABC by a scale factor of 1/3. So let's say we have a scale factor of 1/3, and we'll use the same center here. Okay, so let's say that they give you a triangle once again, and they're going to give you a center point of D right here. We're going to start this the exact same way. So we have a center of D, we have a scale factor of 1/3. Okay, so just like before, we are going to connect our center point through each one of our vertices here. Now I'm going to try that again here. So we're connecting our center point D through our first vertex. We're going to connect that center point D through our second vertex. And we're going to connect it through our third vertex as well. All right, I'm going to move this thing over just a little bit here since we're a bit off. All right, and then I'm going to label this guy A, B, and C, just like we did before. Okay, so this time our scale factor is 1/3. 1/3. So we're going to do the same thing here. We're going to measure our original distances. So let's say that our original distance here is 1 centimeter. Let's say that this is 1 centimeter as well. And then let's call this thing 3 centimeters. Okay, so from our center point to A is 1 centimeter. From our center point to C is 1 centimeter. And then let's say we measure from D to B and we get 3 centimeters. This time, if we multiply those lengths by our scale factor, so 1 times 1/3, 1 times 1/3, and then 3 times 1/3, we are going to get smaller. So dilations don't always grow the figure. If the scale factor is small, so if it's less than 1, it's actually going to cause the figure to shrink. Okay, so our new A value, or our vertex A, is going to be in here. It's going to be 1/3 the distance that it currently is. So that's going to be 0.3 inches, 0.3 repeating inches. Same thing here. So from center point D to C is going to be 1/3 of an inch as well. And then from D to B, so that started out as 3 centimeters. Multiplying 3 by 1/3, we should get 1 inch. So that is now going to be 1 inch. Right, and then if you connect your A prime, B prime, and C prime together here, you're going to get a triangle that is 1/3 as large and 1/3 as far away from your center point. Okay, and obviously make sure that you're using your straight edge on your test. But essentially a scale factor that is larger than 1 is going to grow your figure. A scale factor that is smaller than 1 is going to shrink your figure. Okay. So, other skills here that are going to be helpful is setting up and solving proportions. That's another one that has been giving a few people trouble here. So setting up and solving proportions. These problems are going to look something like this. Okay, so I'm going to do triangles again here. So let's say my old triangle looks something like that. I've got lengths of 10, and then let's say I know that this length is 5. And then you might see something like this. So you got a bigger triangle over here, and you're told that this thing is similar. Okay, so similar figures here. Let me try to do that a little bit better. All right, so same shape. We're just scaling this thing up. So let's say this is 30 units, and that is all we know. Okay, so this is the exact type of thing that you might see on a test here. You are going to be asked to solve for your missing side lengths here, and there's a bunch of them. You might be told which one is the old figure, or you might not be, in which case you get to choose. It is always easier to make your new figure be your bigger one. It's just going to help you get an easier scale factor to work with. But either one can be old, either one can be new. All right, so what you're going to do is you're going to choose a set of side lengths where you know both the old length and the new length. So take a look here. We know that the diagonal of this triangle here is 10. We know that the diagonal of this triangle here is 30. That is what you're going to use to find your scale factor. Okay, so in the other problems we're doing, when we're doing our dilations, you were given the scale factor. This time you have to find it. Okay, so new over old is what's going to give us our scale factor. We're going to take our new length and divide it by our corresponding old length. Right? So our new diagonal length is 30. Our old diagonal length is 10. Okay, if you do that on your calculator, 30 divided by 10, that will tell you that the scale factor is 3. And what that means is this figure over here is 3 times as big as our original or our old figure. Okay, so 10 times 3 gives us 30. That same scale factor is going to apply to every single one of these side lengths. So if we move on to our left side of our triangle here, our old length is 5 units. If we multiply that by the same scale factor, that's going to give us 15. So we got 15 units for this length here. Okay, and we can actually stop there. Oops, sorry. All right, so we're able to solve for this missing side here because the same scale factor is going to apply to every single set of sides. So 10 times 3 gave us 30. 5 times that same scale factor is going to give us 15. Okay? So keeping that same concept here, so I'm going to work with these same triangles. Let's say that we are given, so 10 and 30 again. But this time we want to know, get rid of this here. This is old and this is new. So let's say that we know that this side down here is going to be 20. So 20 units, 20 centimeters, doesn't matter what it is. And we want to know this side here. All right, so you can always find the scale factor. So just like before, if you wanted to do the new diagonal divided by the old diagonal, 30 divided by 10 will still give you a scale factor of 3. But sometimes it's going to be easier or more beneficial to set up a proportion. Okay, and what that looks like is this. So just like we did with scale factor, we are going to do our new length on top over our old length on bottom. But we're going to do that twice. So we're going to set that equal to another new length over another old length. Okay, so we're going to start with the new length and the old length that we know. So we know that our old diagonal length is 10. We know that our new diagonal length is 30. And we're looking for this guy right here. We're looking for our old bottom side length. Okay, so we know the new bottom side length. The new bottom is going to be 20. The old length is what we are going to call x. So x just represents the thing that we do not know. Let's scroll down a little bit here. All right, so this is what has given a few people a good amount of trouble here. So cross multiplying, I'm going to go ahead and make a note here. So when we have a proportion like this, we have a couple of fractions or a couple of ratios that are equal to each other. The way to solve it is called cross multiplying or finding a cross product. Okay, and a cross product is this. We're going to multiply across, so we're going to make an x here. We're going to multiply 30 times x, and we're going to multiply 10 times 20. So multiplying across, forming an x shape here. Okay, so 10 times 20 is going to go on one side of our equation. And then 30 times x is going to go on the other side. You're going to want to use your calculator here, most likely. So 10 times 20 is going to give us 200. 30 times x is just 30x. And now that we have set up our cross product and done our cross multiplying, we're just going to do a little bit of algebra here to finish up. So the way to get x by itself here, we want to get rid of this 30, so we're going to divide by 30. We're going to divide 200 by 30 as well. And then 200 divided by 30 is going to give us a decimal here. It's going to give us 6.6 repeating. Okay, so we have solved for this side here. This is going to be around 6.6 repeating, or you can say 6.7. Okay, let's practice another one of these guys here. Get rid of all this, and again, feel free to pause this video at any point and see if you can guess where we're going here before we get there. All right, let's go ahead and let's just do the same triangle here. This time, let's say that we know our new left side here. Let's say we know that this is 8. And we want to solve for this guy here. All right, so once again here, we're going to do new over old, always doing new over old here. We're going to start with the new and the old length that we know. Okay, so we know both of our diagonals. We know that our new diagonal is 30. We know that our old diagonal is 10. All right, so continuing on with what we know, we also know that our new left side is going to be 8. And the old left side is what we don't know. So the old left side is what we don't know. Okay, and we're always just going to use x. All right, so we're going to go ahead and solve this thing. As always, whenever you have two ratios or two fractions set equal to each other, and there's one value that you do not know, you can solve this by cross multiplying. So 30 times x, 10 times 8, multiplying in this cross pattern here. 30 times x is just 30x. 10 times 8, and you can do that on your calculator, is going to be 80. And once again, we just have a little bit of algebra to do here, so we're going to divide each side by 30. That's going to give us, let's see, 2 2/3, so 2.6 repeating. All right, so our old left side here would be 2.6 repeating. Right, I'm going to pull up the next problem here. Give me just 1 second. All right, so this is the next type of problem that a number of you have been struggling with here. This is really similar to what we were doing earlier. In fact, it is just about the same as what we were doing earlier. It just looks a little bit different here. So here we have triangle ABC. We have triangle A, B prime, C prime. So we got our small red triangle and then our bigger blue triangle here. And you might see something like this, and you might be given some information that looks like this. Segment BC is parallel to segment B prime, C prime. So this is telling you that this line, I've got the symbols here for parallel, these arrows. These two things are parallel to each other, so they're going the exact same direction as each other. Okay, and you might be asked to say, how do you know that these two triangles are similar? And it turns out this is all we really need to know to show that these two triangles are similar. So obviously they share one vertex here, so they both have this point here that they share, which means that they share this angle, right? So that angle, of course, is just going to be congruent to itself. So whether you're looking at the small triangle or the big triangle, they both share that same angle here, angle A. And then the other angles you can actually prove are congruent as well. So you got this angle here and this angle here. These are automatically congruent. The reason why they're automatically congruent is because of these parallel lines here. So you got this line here, you've got this line here. Each one of these has, it's called a transversal, so just a line that runs through them. So this diagonal here is cutting through both of those parallel lines. And what that does is it guarantees that this angle C is going to be the same thing as angle C prime. So angle C and angle C prime are going to be congruent to each other. Okay, so these are corresponding angles. Okay, so corresponding angles that are in the same position, are going to be automatically congruent. Okay, same goes for this angle here and then this angle here. We got a line here from B to C. We got a parallel line from B prime to C prime. Each of these lines has this segment here cutting through them. And that means automatically these two angles that are in the same position here are going to be congruent to each other. So angle B is congruent to angle to angle B prime, corresponding as well. Okay, and then we talked about all you need to really know to prove that two triangles are similar to each other is that two angles are congruent. So we didn't even have to even look at this angle, the one that they share, to know that these two triangles are similar. Okay, so if you were asked to prove these things are similar and then write a similarity statement, your proof would just be this. So just show that they have two congruent angles. And then this is on the back of your reference chart that you can use on the test. You are going to say angle, angle, triangle, similarity. That is how you know that these two things are similar, is that if you have two angles that are the same, so these two and these two, automatically you have similar triangles. All right, so what about if, I'm going to go ahead and get rid of this now. What about if you are given this and you've already shown that these things are similar, and now you want to find some missing side lengths? So let's go ahead and practice that again. It's going to be the same thing as before. Let's say that we know this is going to be 5. So from A to C is going to be 5. And then let's say that we know that from A to B is 2. And then we also know that this is going to be 4 here. And then this is going to be 8. All right, so as always, we are going to set up a ratio here. So our new triangle is going to be our big one. Our old triangle is going to be our smaller red one. Same thing every time. We're going to set up a ratio of our new lengths over our old lengths. Okay, So we're going to start with the 2 that we know. So we know that the bottom of the new triangle is 8, and we know that the bottom of the small triangle is 4. So we're going to set this up, 8 on top, 4 down below, and that's going to be equal to, well, it's going to be equal to our scale factor. So if you wanted to find the scale factor, you can do 8 over 4 on your calculator, and that's just going to be 2. Right, so scale factor is 2. But let's say you didn't care about that and we're just looking for our missing side lengths. What we can do is move on to a new length and an old length that we don't know. Okay, so let's start here. Let's start with our diagonals. So the new diagonal, we don't know what it is, right? So we don't know from A to C prime. We do know our old diagonal though, so we know that it is 5. Okay. As always, we're going to go ahead and just call our new length that we don't know x, and then we are going to cross multiply. So 8 times 5, 4 times x. Let me make those look a little bit nicer. 8 times 5 is going to be 40. 4 times x will just be 4x. And then last step to finish up here, we're just going to divide each side by 4, and we get our value, that is x equals 10. All right, so what were we solving for here? We were solving for our new diagonal side length here. So that means this entire length from A to C prime is going to be 10. And that means, so if our entire length is 10 and we already have 5 units here, that must mean this other length is going to be yet another 5 units. Okay, so from here to here is going to be 5. All right, so I hope that helps. I'll see you in class, and let me know what other questions that you still have.